Earlier, what we had learned about was that when you combine stocks into a portfolio, we saw this over here in this table, we were able to calculate the not only the expected return, but also the standard deviation of the portfolios. But we calculated them by first calculating the individual year-by-year returns of the portfolio, and then averaging for the expected return, and then calculating the sigma for the portfolio return. But we also know that this number of 10%, which is the return of the portfolio, I can calculate this directly by applying this formula. Is there a similar thing that I can do for sigma, for the standard deviation of the portfolio? And the answer is yes. The formula is a little bit complicated, but we'll break it down into its component parts and see what it means over here. So the formula says that the variance of a portfolio is the weight squared for the first stock multiplied by the variance of the first stock, weight squared for the second stock multiplied by the variance of the second stock, plus 2 times W1, W2, standard deviation of stock 1, standard deviation of stock 2, and then multiplied by a variable that we had learned in the first part of chapter 12 that we call correlation. Correlation between stock 1 and stock 2. Once I have the variance of the portfolio, I can take the square root of that variance, and that would give me standard deviation of the portfolio, standard deviation of portfolio P. So yes, there is a formula that could have given me the same result that we saw before. But to get that result, I have to know the correlation between the two stocks, between A and B. So the overall variance of the portfolio, or the risk of the portfolio, sigma P squared, is made up of 3 components. Component 1 is W1 squared, sigma 1 squared. Component 2 is W2 squared, sigma 2 squared. And component 3 is 2 times W1, W2, sigma 1, sigma 2, correlation 1, 2. So the first part measures for me the standalone risk from stock 1. The second part measures for me the standalone risk from stock 2. And the third part takes into account the interactive risk to see if some of the unsystematic risk that we had spoken about before, if some of that unsystematic risk can be mitigated, can be reduced, can be eliminated if possible. So that's what the third part is trying to measure. So the expected return of the portfolio, that's the easy part. Expected return of the portfolio is the weighted average of the stocks that make up the portfolio. That's the easy part. The risk of the portfolio is lower than the weighted average of the individual stock risk, as long as correlation between 1 and 2 is less than +1. For any number that is less than +1, it will be less than the weighted average, as we can see on this equation over here. Because this part, if it is anything other than +1, will reduce the overall risk of the portfolio. That's why we saw in this table over here, that's why in this table, the risk of these portfolios was less than the individual risk of the stocks, of any of the stocks, because of that correlation. Okay. So now that we know what correlation is and how it impacts the overall portfolio, it explains to us the power of diversification. it conveys to us that yes, we have to diversify our risk. We have to spread the risk among as many possible stocks, as many stocks as possible. Of course, in the context of this course, we are only limited to 2 stocks. If you take my advanced financial management course or investment course later on, we will get a little bit more deeper into what happens when I add a 3rd, 4th, 5th, or a 500th stock to my portfolio. But over here, our discussion is primarily limited to 2 stocks, 1 and 2. So here we have a portfolio made up of Apple and Microsoft. So this is weight of 1, weight of 2, sigma 1, sigma 2, and this would be correlation 1, 2 between Apple and Microsoft. Correlation of Microsoft with Apple. So what would be the risk of this portfolio? Made up of half of Apple and half of Microsoft. I take the weight of Apple, square that, multiply that by the standard deviation, squared. Essentially, this is the variance. Same thing, weight of Microsoft, squared, multiplied by the variance of Microsoft, 2 times weight of Apple, weight of Microsoft, standard deviation of Apple, standard deviation of Microsoft, and this is the correlation between Apple and Microsoft. So this is correlation between 1 and 2. And if we do the math, it comes out to 29.9%. So this gives us first variance, then we take the square root of the variance, we get that in decimal form, then we can convert that into a percentage form, 29.9%. Okay, similarly, you can practice this with between Apple and Starbucks and so on and so forth. And similarly for other possibilities, other examples on your slides over here. So work through them to learn about the different ways in which you can apply this formula. It's important for you to practice this formula. Okay. Now comes the next part of it. What happens if I go from 1 to 2 stocks and then I add more and more stocks, get up to 100 stocks, go up to 1,000 stocks? So what happens for a portfolio that is made up of large number of stocks? And we saw the answer to this a little bit in chapter 11. We will repeat this over here. So when I started with 1 stock, I had my portfolio risk was the risk of that 1 stock. Forget about how I get these numbers. Right now, concentrate on what these numbers mean. When I add a second stock to my portfolio, because the correlation between stock 1 and stock 2 was anything other than +1, it was any number less than +1, then what happens? I reduce the risk of my portfolio. So I go from here to, let's say, here. When I add a third stock, I reduce the risk of my portfolio further. I add a 4th stock, I reduce the risk of my portfolio further, and I keep on doing that until I get to 1,000 stock. And then I take all that and I plot this over here. And what does that plot show? That as I add more and more stocks to my portfolio, overall risk decreases. That's why this blue line is curving down. But beyond a certain point, it practically becomes a horizontal line. Beyond a certain point, like I would say somewhere here, maybe at about 20, it practically becomes a horizontal line, telling us that risk is not reduced any further. So, tells us 2 things. That number 1, risk reduction is possible. Risk reduction is possible. And number 2, beyond a certain point, risk reduction is minimal. The part where risk reduction is possible, we call that unsystematic risk or diversifiable risk. As we can see, we are reducing it. We are going down. We are going down. We have reduced risk. As I added more and more stocks to my portfolio, I'm reducing risk. So that's unsystematic risk or diversifiable risk. And then beyond a certain point, I cannot reduce risk any further. Pretty much a vertical line. I cannot get rid of this risk. That's my systematic risk or non-diversifiable risk, also known as my market risk. This is the risk that is market-wide. Every stock in the economy bears risk from changes in interest rates, changes in inflation, and so on and so forth. This risk is diversifiable, this risk is not. So this risk I can get rid of, but this risk I cannot get rid of. That means if I am investing in a large portfolio, first of all, there is no reason for me not to diversify. So the first lesson is, yes, diversification matters. Diversify. Add more and more stocks to your portfolio. The more you add, the more likely you are to get rid of this risk. And the more you can get rid of this risk, the only risk that you need to worry about is then the market risk. So if I'm an investor, what risk should I expect compensation for? I should expect compensation for this risk. What risk I should not expect compensation for? I should not expect compensation for this risk. It's not material because I can simply get rid of it by adding more and more stocks to my portfolio. So if I'm going to get compensation for this market risk, then I have to know how to measure that risk. So let's talk about how to measure that market risk. Which brings us to the role of what we call the market portfolio. A market risk can be proxied through a market portfolio, which would be, first of all, before I get to the market portfolio, I just want to quickly recap this equation that we saw earlier, that the market value of any firm is simply the number of shares outstanding for that particular firm multiplied by the share price for that firm. So this is something we had seen earlier, just a quick recap over here. So now back to the market portfolio. The market portfolio can be proxied by what we call the market index. And there are several ways in which this market index can be tracked. What we will limit our discussion to is the S&P 500 index. The S&P 500 index is an index of stocks, is a portfolio of stocks, of 500 stocks that are chosen by the Standard & Poor's Corporation that represent the 500 largest stocks in our market. These 500 stocks, as a group, represent a small section of the total number of publicly traded stocks. And yet, they represent close to 75%, 70 to 75% of the total market value of the market, the total market capitalization, which means I have taken N times P for each stock and I've added them all up for all stocks in the economy, and then I looked at the market capitalization for these 500 stocks, and these 500 stocks represent close to 70% of the overall market capitalization for the entire stock market. So it tells you that pretty much as goes these 500 stocks, so goes the entire stock market. Even though there are over 6,000 stocks trading in the market, these 500 stocks, for all practical purposes, represents the biggest block of those 6,000 stocks. But for our purposes, this S&P 500 also represents a market portfolio. A market portfolio that is well diversified. That means it is devoid of any unsystematic risk. All of that unsystematic risk that we had talked about before, all of that unsystematic risk is gotten rid of. We are somewhere in this zone over here. So the only risk that is remaining for us is the market risk. So that's our market portfolio. And what we now want to know is what is the relationship of each stock that I have to this market portfolio. How does one particular stock relate to that market portfolio. That one particular stock could be anything. Could be Google, could be Apple, could be Microsoft, could be Coca-Cola, could be anything. So how do we track that? One way to track that is to do something like this. I'm going to skip all of that and come over here. So over here, what I'm looking at is what is described as the monthly return, of course with the qualified excess. I'll explain what excess is in a minute, but all practical purposes, I'm looking at monthly returns of Apple against this market portfolio. And what do I see? I see, for example, over here that the blue bar representing the market is doing well. Apple is doing slightly better. Apple generally does slightly better than the market. Not always, sometimes there are exceptions like over here, but generally. But also when the market is doing poorly, Apple does slightly worse than the market. So that means we can say that Apple is sensitive, more sensitive to changes in the market. It is certainly correlated to the market, but it is also sensitive to the way it changes when the overall market changes. Now to this word excess. The word excess simply means it's the return on the stock. We're looking at return on, let's say, Apple, minus the return on a risk-free stock, a risk-free asset. You know from chapter 11 that would be the yield on T-bills, treasuries. So this is what we are looking at. Excess is the return on the stock above the T-bill yield. Sometimes we can also describe this as the risk premium. It is the additional compensation that you receive for the stock above and beyond the risk-free yield. So just by looking at month to month, changes in Apple's return to changes in the overall market, I can see that there is a correlation. I can also see that there is a degree of sensitivity to Apple that is more than what happens to the overall market. How can I quantify this understanding? To quantify this understanding, the first thing I do is generate these green dots. And these green dots are called scatter plot. Essentially what these green dots represent, we take observations month by month and I plot them on this green dot. For example, this dot over here represents what happened in May 2009. Apple did 7.9%. The return on Apple stock was 7.9%. Return on market portfolio on the S&P 500 was 5.3%. So that's 5.3% and that's 7.9%. Which means on the x-axis, I'm measuring the return on my market portfolio, and on the y-axis, I'm measuring return on my Apple stock. So each of these green dots represent a particular point in time. For example, this dot is for May 2009. Once I have these dots, I can see that there is a trend. These dots are kind of bunched up like this, linear, not as linear, but certainly trending upward. I can then give it more meaning by drawing what is called the line of best fit, or the line of least square errors, or simply the regression line, and that's the red line there. Okay. That red line is called the regression line, and each regression line has two characteristics. The important characteristic for us over here is this slope, which we call beta. And beta is simply defined as rise over run. What is rise? Rise is the change in the return on Apple. That's the vertical distance. What's the run? It's the horizontal distance, which is the change in the return on the market portfolio. So now if beta is 1, what does that mean? It means if the market return changes by 10%, the stock return or Apple return will change by 10%. If beta measured out to be 1 in this regression. If beta measured out to be 0.5, it would mean that if market return changes by 10%, stock return would change to 5%. And if beta is 1.5, it would mean if market return changed by 10% up or down, then the stock return would change by 15% up or down. So beta essentially gives us a response, the average response the stock return has for changes in the overall market return. That means it tells me the degree to which the stock is sensitive to changes in the overall market return or the overall systematic risk. Because after all, in the S&P 500 portfolio, in the S&P 500 index, there is virtually no unsystematic risk. It is entirely made up of systematic risk. So that's what beta is measuring for us. Now, once we have measured beta, then what do we do with it? What we do with it is to use this measurement of systematic risk. This is our measure of systematic risk. I use it to measure expected return for that particular stock. So if beta for Apple is, let's say, 1.2, then I will use that 1.2 to measure what expected return for Apple ought to be. And what does this equation tell us? This equation tells us that the expected return for this particular stock, Apple, or any stock, would equal, first, the minimum would be the risk-free rate, which is the yield on the treasury. Plus, I will receive a compensation. A compensation that is the risk premium for the security. This entire red box is the compensation for the riskiness of Apple stock. But how is that compensation measured? It is measured by taking beta and multiplying that beta with this particular part. This blue circle measures what is called the market risk premium, because it measures for you the return on the market portfolio, which is the S&P 500, above the return on the treasury bill. It's kind of like the excess return definition. So it's a simple, elegant equation that governs for us the relationship between expected return and systematic risk. Because in the market, notice what's happening. For every stock, whether I is Apple, or I is IBM, or it is Microsoft, or it is Google, or it is GE, or Ford, or Caterpillar, or Starbucks, all stocks have the same yield or are governed by this, or impacted by the same yield on the treasury bills, which is these two. All stocks are impacted by the same return on S&P 500 index, the market portfolio, the market index or portfolio, governed by the same return on the market index or the market portfolio. So what's unique then? How will the return on Apple differ from the return on Microsoft? Well, the difference will be based on their betas. So when I have the beta for Apple, which would be unique to Apple. I will get the expected return for Apple. When I substitute the beta for GE, I will get the expected return for GE. So that situation is described over here. So here I have beta for Coke, expected return for Coke. Beta for Apple, expected return for Apple. So this blue line is called the security market line, and this blue line is essentially measuring this. So assume that the risk-free return is 3%, and assume that Rm minus Rf is 6%, and assume that beta for Apple is 1.2, then what does it say? This is 7.2 plus 3, which is 10.2. That's what it says. If beta for Apple is 1.2, its expected return would be 10.2%. So that means the return on Apple is 7.2% more than the Treasury bill. And why is it 7.2%? Because beta for Apple is 1.2. It is 1.2 times the market risk premium. So Rm minus Rf is 6%, which means what is Rm? If Rf is already 3, Rm would be 6 plus 3, Rm would be 9%. And we see this over here. Notice this, that here is market beta. Beta for the market is always 1. By definition, it is 1. Then return for market is 9%. So this gives us a scheme on what the expected return and beta relationship is expected to be. What it tells us that as we increase risk of a stock, its expected return should go up. That's why this blue line is positively sloped. When we get to this point over here, it measures for us the risk-free return, which is 3%. And what is the beta for the Treasury? Beta is 0 at that point. That means by definition, the beta of a risk-free security is 0. It's a risk-free security. It has no systematic risk. So this gives us a visual depiction of what capital asset pricing model actually means. And then you can go back over here and practice some of these problems. For example, over here, let's see. The risk-free return is 5%. It says market risk premium is 7%. So risk-free return, that is RF. What is 7%? This is RM minus RF. That's the market risk premium. So you have to identify the variable properly. And this is beta. So we put this into our equation. RF is 5. Rm minus Rf, that whole thing is 7. Beta is 1.5. That means this is 15.5. So this is 5 plus 10.5. Right? 5 is the return on the Treasury bill, and I'm receiving a 10.5% compensation for the fact that beta for Best Buy is 1.5. It is 1.5 times the market risk premium. That's the way you would interpret this equation. Okay. And that would conclude for us chapter 12.